This is PreCalculus A. This is Unit 6, Conic Sections, Lesson 6, Hyperbolas. Let's go ahead and clear some space here to get started. I've got a problem I want to take a look at here. So we're going to take a polynomial function in standard form. So 9x squared minus 16y squared minus 54x plus 64y equals 127. Remember, the general form is ax squared plus vxy plus cy squared plus dx plus ey plus f equals 0. Okay? And this isn't exactly in standard form, so let me put it in standard form. So minus 127 equals 0. That would be better. Okay. All right, and so we can tell there's no v term here, so a in this case is 9, v is 0, and c is negative 16. So v squared minus 4ac, the discriminant, is 0 squared minus 4 times 9 times negative 16. Doesn't really matter what it is here, but a negative times a negative is a positive large number. Okay, so since it's greater than 0, we know this is not a parabola, because that would be equal to 0. It's not less than 0, so it's not an ellipse or a circle. It's greater than 0, that makes it a hyperbola. Okay, so we know it's a hyperbola. Another way to tell is it has different numbers on the x squared and the y squared coefficients, and they are opposite in sign. All right, so let's see if we can convert this here. So we're going to complete the square on the x's. In order to do that, let's group the x's together. 9x squared minus 54x minus 16y squared plus 64y. Move the 127 to the other side. Factor a 9 out of the x squared, the x terms here. So x squared minus 9 times 6 is 54. Leave some space because we're going to add something to make it a perfect square. Minus 16, so we can factor out a negative 16, y squared. 16 times 4 is 64, so minus 4y plus something, leave some room, 120 equals 127. Okay, and let's go ahead and get rid of this because this is going to be cramping my style here. Getting in my way. All right, so let's see what we add. Well, negative 3 plus negative 3 is 6, so negative 3 times negative 3 is 9. So I'm going to add 9 to both sides of the equation. Negative 2 plus negative 2 is 4. And actually, yeah. Oh well. Negative 2 plus negative 2 is 4, so negative 2 times negative 2 is 4. So we're going to add 4 to both sides here. Okay? And let's see what we get. This is 9 x minus 3 squared. Okay, minus 16 y minus 2 squared equals 127 plus 9 plus 4, or 127 plus 13 is 140. And I think I've got a mistake here somewhere. Let me check. Of course, I found the problem. We can't just willy-nilly go adding 9 and 4 to both sides. Okay, what we add to both sides is actually determined by what we're multiplying by. I added 9 here. I actually added 9 times 9, 81. when I put that 9 there. When I added 4 here, I actually added negative 16 times 4, right? Which is 40, 50, 64, negative 64. Okay, to that side. All right. So don't forget, when you add inside of parentheses, you're actually adding, by the distributive property, that times the number outside the parentheses. Okay, 127 plus 81 minus 64. (127 plus 127 plus 81 minus 64, 144. There we go. Okay. All right, and now it's much simpler here. Now I'm going to divide both sides by 144, which is, by the way, 9 times 16. So when we divide by 9 and 16, the 9's canceled. We get x minus 3 squared over 16 minus y minus 2 over 9, right, equals 1. And just one more adjustment, x minus 3 squared. 16 is 4 squared. Y minus 2 squared. 9 is 3 squared. Equals 1. And so now we can graph this. Here's how we graph this. Okay, here's the origin. We're going to graph the center of the hyperbola. Center of the hyperbola is at 3, 2, using opposites there. 3, 2. Okay. And the displacement along the x-axis, along the x direction, is plus or minus 4. So 2, 4, and 2, 4. Displacement along the y-axis direction, up and down, is 3, 2, 3, 2, 3. So you can imagine, if you will, a box. Okay, here's a box. Okay, and here's our box. And we can draw the diagonals of our box. Now the hyperbola exists outside the box, not inside the box, as in the case of the ellipse. So it has a slope of 3/4. Up 3 over 4, up 3 over 4. So it has an asymptote going out here, and an asymptote going negative 3/4 as well. Okay, and the x term is positive, so the displacement or the orientation is left to right. So the vertex is right here at the middle of the side of the box. So we can identify the vertices as negative 1, 2, and 2, 4, 6, 7, 2. Okay. What's more is we can identify the foci. There are foci of the hyperbola, just like there are foci of an ellipse. Okay, here we go. All right, and so we can determine the foci. The foci are equivalent to the diagonal of the box, half the diagonal of the box here. Look at this right triangle. This side is 3. This side is 4. Well, 3 squared plus 4 squared equals r squared, or diagonal squared. This is going to be 5. This is a 3, 4, 5 right triangle. And so the focus here is right down here, 5 to the left. The focus here is, in this case, negative 2, 2. And this focus is right here, 5 to the right of the hypotenuse center, or the hyperbola center. 2, 4, okay, and that's 2, 4, 6, 8, 2. Okay, so the Pythagorean theorem helps us to find the focus or the foci as well. All right, that's it.